On the 1st of July, NASA detected a mysterious object speeding toward Earth, and some actual bona fide experts think it might not be your typical space rock or maybe any kind of rock.
When astronomers first detected the object now making its way into the solar system, the data immediately stood apart from anything previously logged. It was not a faint speck or a subtle streak of light across deep sky surveys. It was immense, a body so large that its brightness alone commanded immediate attention. Even at a staggering distance beyond the orbit of Neptune, its reflected sunlight rivaled the luminosity of known dwarf planets. The trajectory, when mapped, revealed something even stranger. Its inbound course appeared to intersect directly with the path of 3I/Atlas, the third recognized interstellar visitor cataloged by humanity. This was not a minor brush with the outer solar system. This was a colossal object seemingly aimed, either coincidentally or by some deeper orbital mechanics, at a rendezvous with one of the rarest kinds of travelers, the kind that drifts in from other star systems. Before we start, smash the like and subscribe buttons for more updates. The discovery sparked a storm of questions. To begin with, the sheer scale of the object upended expectations. Most bodies discovered on long-period or hyperbolic trajectories are icy fragments, kilometers across at most. They streak through and depart, leaving only transient dust tails or spectral fingerprints of volatiles. But this new intruder dwarfed such comparisons. Estimates suggested it spanned hundreds of kilometers, edging it into the category of a world rather than a fragment. It was larger than any comet ever observed, and more massive than many asteroids in the main belt. To suddenly find such a thing sliding inward from the dark fringes of interstellar space shook the foundations of solar system science. Nothing in the established catalogs of interstellar objects, Oumuamua or Borisov, or even Atlas, prepared astronomers for something of this magnitude. As the orbital simulations refined, the astonishing detail emerged that its projected path converged with 3I/Atlas itself. Atlas had already been a scientific curiosity, a loosely bound, icy, interstellar body that had fragmented dramatically as it passed through the inner system. It had drawn attention because it was only the third confirmed interstellar visitor, its origin traced to some distant star long ago. For a gigantic newcomer to align itself toward Atlas seemed beyond coincidence. Some speculated about gravitational shepherding in deep interstellar space. Perhaps both bodies once linked in a distant system, ejected together and now reuniting under the pull of the sun. Others imagined the encounter as an unprecedented chance to observe two alien wanderers interacting within the confines of our own solar neighborhood. The implications of such an event cannot be overstated. For decades, interstellar objects were purely theoretical, the stuff of probability calculations suggesting that rogue comets and asteroids should occasionally wander across the solar boundary. The arrival of Oumuamua in 2017 was a seismic confirmation, followed by Borisov in 2019, and then Atlas in 2020. Each was remarkable in its own way, yet each was fleeting, small, and difficult to study in detail. The new giant object altered that equation completely. Its size ensured it would remain visible for a long time, its brightness allowing instruments across the globe to capture spectra, surface mapping, and even rotation characteristics. The collision course, or near encounter, with Atlas elevated the stakes further, creating the possibility of interstellar to interstellar interaction. That scenario had never been imagined in practical terms. The scientific community quickly recognized that this was not just a question of curiosity, but of profound cosmological importance. If two interstellar objects crossed paths within our solar system, the event could offer insights into the distribution of such bodies in the galaxy. Were they more common than once thought? Did they travel in pairs or groups, remnants of disrupted planetary systems, or was this simply a cosmic accident, a rare crossing of two unrelated trajectories? Observing their meeting promised to answer questions not only about the objects themselves, but about the dynamics of interstellar migration. The implications stretched into planetary formation theory, stellar neighborhood mapping, and even the search for habitable environments elsewhere. Beyond the scientific allure, the sheer spectacle carried a kind of mythic resonance. Humanity had grown accustomed to comets arriving like heralds, their tails flaring above the Earth. But the notion of a massive foreign world drifting inward from the void struck a different chord. It was not just another cometary visitor. It was a planetary-scale body, untouched by the sun until now, carrying with it the chemical memory of some other star. Its composition, once analyzed, could tell stories of processes occurring light years away. It might reveal isotopic ratios never seen in local materials, or organics assembled under alien conditions. Every photon reflected from its surface or emitted in outgassing carried a message across stellar distances. As the data poured in, teams around the world coordinated observations. Infrared telescopes measured its thermal profile, confirming its bulk and density. Radio observatories prepared to listen for natural emissions from charged particles interacting with the solar wind. Even planetary defense networks, usually tasked with monitoring near-Earth threats, shifted their focus to the newcomer, intrigued by the trajectory's uncanny alignment. For the first time, discussions arose about whether probes could be hastily redirected to intercept it. The distances were vast, but so too was the object, presenting a target unlike anything previously encountered. The interaction with 3I/Atlas was modeled with growing anticipation. While Atlas itself had fragmented, portions of it still drifted along its inbound path, clouds of icy debris trailing behind. The potential for the giant newcomer to collide, disrupt, or simply pass through that field raised possibilities of visible interactions. Dust plumes, impacts, or gravitational scattering could all be within reach of observation. Astronomers speculated about the sight of interstellar material crashing against interstellar material under the sun's gaze, a cosmic duet billions of years in the making. For planetary scientists, this was akin to watching two fossils from alien worlds collide on the stage of our own system. The philosophical undercurrents were just as powerful. Humanity has long gazed outward, imagining contact with distant realms through radio signals, spacecraft, or even speculative encounters with other civilizations. Yet here was a different kind of contact, not with intelligence, but with matter itself. With the raw geology and chemistry of other stars delivered directly into our skies, the gigantic object bore silent witness to ancient processes elsewhere, and its approach forced reflection on the interconnectedness of the galaxy. Just as meteorites deliver fragments of Mars and asteroids to Earth, this body delivered a planetary shard from another sun, a bridge across the gulfs of space. Attention inevitably turned to its physical character. Would it be icy like a supercomet, its surface erupting into plumes as it neared the sun? Or would it be rocky and inert, a silent boulder wandering through? The immense size suggested gravitational cohesion, perhaps even differentiation into layers like a true world. If so, it could possess a core, a mantle, and a crust sculpted under conditions no human eye had ever witnessed. The prospect of comparing its isotopic ratios to solar system standards was intoxicating. A single rock retrieved, even in microscopic fragments through natural shedding, could rewrite our understanding of stellar nucleosynthesis and galactic chemical evolution. Speculation inevitably grew around its origins. Perhaps it had been ejected from a young system with giant planets stirring their surroundings into chaos. Perhaps it was the remnant of a destroyed world, flung outward when a star swelled into a red giant. It could even be the survivor of a binary star disruption, a body wandering for eons before crossing our path. Each possibility painted a picture of cosmic violence and creation, scenarios played out millions of times across the galaxy but never directly witnessed. By tracing its trajectory backward, astronomers might one day pinpoint the region of space it once called home, connecting our sun's immediate neighborhood to distant stellar associations. The idea that it seemed to be targeting 3I/Atlas only deepened the mystery. Celestial mechanics could explain coincidence, yet the human imagination resisted. How could two interstellar visitors converge so neatly within the vastness of space? Some entertained exotic ideas of capture or shared origin, others mused on resonances we did not yet understand. Whether coincidence or not, the drama of two alien wanderers crossing paths near our sun was a narrative that resonated deeply, blending scientific rigor with a sense of cosmic destiny. For those who watched, it was not just an astronomical event, it was a chapter in the ongoing story of humanity's place in the galaxy. As weeks turned into months, the object's presence grew undeniable to the naked eye through telescopes. Amateur astronomers joined professionals, their images flooding forums and social media. The sense of collective observation united communities worldwide, reminding all that the sky is a shared heritage. The sight of a massive alien world gliding silently inward became a source of wonder and inspiration, a reminder that the universe is not static, but alive with motion, encounters, and mysteries yet to be revealed. The approach to Atlas loomed closer. Models predicted turbulence in the dust clouds surrounding the earlier interstellar visitor. Instruments prepared to detect flashes of impact or gravitational wakes as the newcomer passed. The possibility of mutual illumination, dust particles scattering sunlight into radiant arcs, drew comparison to auroras on a galactic scale. It was a performance no human generation had seen before, and perhaps none would see again. Each calculation, each observation, each moment drew humanity deeper into the realization that we were witnesses to a cosmic rarity, the meeting of two exiles beneath the warmth of our own star. This unfolding event underscored the fragile yet wondrous nature of existence within a galactic context. The gigantic object was more than a mass of rock and ice. It was a messenger, a fragment of a distant system, and now a participant in a rendezvous that tied together strands of cosmic history. Its journey into the solar system, its apparent targeting of 3I/Atlas, and the unfolding spectacle of their convergence invited awe not only for what it revealed but for the reminder that the solar system is not an isolated island. Instead, it is a crossroads where the galaxy occasionally leaves its signatures, bold and undeniable, for us to witness and ponder. The countdown toward the moment of closest approach between the massive intruder and 3I/Atlas fueled an unprecedented wave of preparation, speculation, and imaginative exploration. What distinguished this period from other astronomical events was the sheer scale of unknowns layered upon the known data. The orbital solutions were increasingly precise, but the nature of the body remained elusive. The community of astronomers, astrophysicists, planetary geologists, and even philosophers found themselves grappling with questions that bridged empirical study and existential wonder. A gigantic object, never seen before within the confines of the solar system, was moving closer by the day. Its destiny to intersect with the path of an interstellar fragment already drifting in our skies created a once-in-an-epoch tableau, and humanity, for the first time, had both the instruments and the intellectual framework to watch it unfold. The technical challenges of observing such an object were formidable. While its size guaranteed brightness beyond that of a typical comet, it was still an alien body emerging from the depths beyond the Kuiper Belt. Observing from Earth demanded coordination across continents. Southern and Northern Hemisphere observatories synchronized their efforts to cover every possible phase of its journey. Space-based platforms added another layer of precision unaffected by Earth's atmosphere, capable of capturing spectral data from the ultraviolet through the infrared. Each wavelength told a different story, whether about volatile outgassing, surface composition, or thermal properties. Together, these observations formed a mosaic of information, gradually peeling away the mystery of what this colossal visitor was made of. Scientists were not content with remote observation alone. Proposals emerged almost immediately to dispatch robotic emissaries. Missions already in development, designed to chase comets or explore asteroids, were reconsidered for redirection. Engineers calculated trajectories with feverish intensity, weighing the possibility of a gravity assist to slingshot a probe into an intercept path. While the timescales were short, the incentive was overwhelming. To encounter such a body up close, to map its surface and directly sample its environment, would be a triumph that could eclipse decades of planetary exploration. Even a flyby, fleeting though it might be, could capture data no telescope could provide. Surface geology, magnetic field strength, particle environments, and, if luck favored, fragments of ejected dust for onboard analysis. As humanity prepared for contact, the cultural response mirrored the scientific frenzy. Throughout history, comets and celestial wanderers inspired fear, reverence, and myth. Now, in the age of space science, that instinct to weave narratives had not vanished. Poets, artists, and storytellers found themselves captivated by the vision of a planetary-sized stranger arriving unbidden from the void. The symbolism was irresistible. A wanderer bearing secrets from another sun, converging with a fellow exile, and choosing the stage of our solar system for its passage. Fiction writers imagined civilizations from distant worlds that might once have gazed upon this same object as it departed their skies. Musicians composed symphonies to echo its slow, deliberate movement across constellations. Even those who did not follow the science felt the resonance of a rare event that seemed to connect human existence to the broader galactic stage. The question of its internal structure became a focal point of speculation. If it was icy, its size suggested a deep reservoir of frozen materials, perhaps ammonia, methane, carbon dioxide, and exotic volatiles rare in our system. If rocky, it might have once been part of a shattered planet, flung outward during a violent era of stellar evolution. The debate between icy versus rocky composition was not trivial. It carried immense implications for the diversity of planetary systems in the galaxy. A rocky giant suggested that large terrestrial worlds were being disrupted and ejected more often than once thought. An icy behemoth pointed toward distant, cold planetary nurseries rich with frozen matter. Either way, the discovery challenged the boundaries of known planetary formation theory. Its sheer size hinted at another possibility: differentiation. Many smaller bodies in our system are irregular, loosely bound, their gravity insufficient to mold them into spheres. This newcomer, however, had mass enough to round itself, to collapse under its own gravity into a coherent world. If so, it was not a mere fragment, but a planetary relic. The thought of such a relic traveling between stars expanded imaginations. Had it once possessed moons, stripped away during ejection? Did tectonic or volcanic processes ever shape its crust? Was it, in some inconceivable past, capable of supporting transient atmospheres or oceans? Each possibility cast it less as a simple traveler and more as a refugee, carrying with it echoes of a forgotten planetary history. The interaction with Atlas intensified speculation. Atlas had fragmented, leaving behind streams of dust and icy shards, a ghost of its former self. The alignment of trajectories suggested the giant newcomer might pass directly through this debris field. The consequences of such a passage were both scientifically thrilling and visually spectacular. Impacts between fragments could produce observable flashes of light, new plumes of dust, and even temporary comas of vaporized material. Telescopes could capture the chemical signatures released, allowing comparison between the two interstellar bodies. If their compositions diverged, it would suggest vastly different origins. If they matched, it could strengthen the argument that they once hailed from the same distant system. The alignment also offered an unparalleled natural experiment in gravitational dynamics. The newcomer's immense mass would subtly tug at Atlas fragments, shifting their orbits and dispersing their clouds in ways that could be carefully modeled. Observing this process in real time would teach scientists about the gravitational interplay between interstellar objects and how such encounters might play out across the galaxy. Every wobble and drift would be recorded, every filament of dust tracked, yielding equations and models that could guide our understanding of how rogue planets and comets populate interstellar space. This was not just about mechanics. For geochemists and astrobiologists, the encounter hinted at a deeper prize, the exchange of material between star systems. If dust from Atlas adhered to the newcomer, or if fragments collided and coalesced, then the event represented a literal transfer of matter across interstellar boundaries. The seeds of one star's chemistry might embed themselves in the geology of another. Such exchanges could be the galactic equivalent of cross-pollination, scattering the ingredients of life across vast distances. If organic compounds were detected in either body, their mingling would resonate with the panspermia hypothesis, the idea that life's building blocks could be spread through space by wandering bodies. The spectacle above would not merely be a show of light and dust. It could symbolize the galaxy's grand cycle of material, the cosmic circulation that knits stars and worlds together. The object's journey also invited new thought experiments about time. This body had likely been adrift for millions, perhaps billions of years. In that time, stars had been born and extinguished. Civilizations may have risen and fallen elsewhere, and entire galaxies had shifted their patterns. Now, by chance, it intersected with the timeline of humanity. Its presence underscored the vastness of cosmic scales and our fleeting moment within them. To watch it glide inward was to witness not just an object, but an ancient survivor, carrying with it the memory of times and places long lost. Every kilometer it traveled through our skies was a reminder of the temporal bridges that connect epochs far beyond human comprehension. The anticipation for what would happen at perihelion, the point of closest approach to the sun, grew daily. Would the object erupt in massive geysers as its frozen volatiles sublimated, creating tails longer than any cometary plume observed? Would it remain inert, a silent black silhouette moving against the stars? Either scenario promised revelations. If active, its outbursts would reveal deep reservoirs of material untouched since its formation. If inactive, its rocky durability would confirm it as a planetary remnant, stubbornly resisting the sun's heat. In either case, the encounter with solar radiation would expose truths hidden in its cold exile. Even as the object was studied scientifically, it began to reshape human imagination about the universe. The very fact that something so massive, so alien, and so perfectly timed could arrive within the narrow window of our observational capabilities felt uncanny. It reawakened ancient questions about destiny and meaning in the cosmos. Were such encounters purely statistical inevitabilities? Or did they suggest hidden patterns in galactic dynamics? Was humanity simply fortunate, living in an era when instruments could capture the drama? Or did our age represent a tipping point in our relationship with the universe? These questions, unanswerable though they may be, accompanied the scientific analyses, giving them a backdrop of wonder. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on a gigantic object entering our solar system? We want to hear from you. Thank you for watching, and see you next time.